Hello, this movie is for Learning Target 2 of Unit 4, Triangle Congruence using side, 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 and side, angle, side. There are times when you do not need to know that all the sides and all the angles are congruent in order to know if two triangles are congruent. Sometimes we only need to know that three conditions are true, and we can tell that two triangles will be congruent with those three conditions. We saw that we analyzed a bunch of different shortcuts from our in-class time together to see which ones worked. And so the shortcuts that worked were side, 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 angle, side, angle, angle, side, and angle, side, angle. I like to think of it as there are two that don't work. And the two that don't work is when we have donkeys, ASS, angle, side, side, with batteries, AAA batteries, or donkeys on vacation. We know that those two shortcuts do not work in order to prove two triangles congruent, but all of these shortcuts do. So today we're going to look at these two. Our first postulate is side, side, side. This says if I have three sides of one triangle congruent to three sides of another, then boom, I can go ahead and say triangle's congruent. I don't need to prove anything about the angles because there's no way to get another triangle with those three sides congruent. They're going to be congruent. So let's look at this proof. Here we have a roller coaster, which I do not recommend that you do roller coasters. They are very scary. Anyway, more to the point. In this proof, LM is congruent to NP, marked already on the diagram. LP congruent to NM, marked already in the diagram. We want to prove the two triangles we see here congruent. So for our reasoning, the first line is because given. We can see that we were given that information. For line 2, we have LN congruent to LN. Now that is equal to itself, its reflexive property. Now, do we have enough to say the two triangles congruent? Now back in Learning Target 1, we had to prove all angles congruent as well. We have a shortcut now, and it is side, side, side. Is it okay to just put SSS? Yes, it is. It's a shortcut known throughout the land. We're going to the next slide. We also learned about side, angle, side. This means two sides of one triangle with its included angle. Now what I mean by that is the angles between the two sides that you know is congruent to another triangle's two sides and its included angle. Then you can say that the two triangles are congruent. You actually use this quite a bit. So if you've ever tried to see if a box or a table or some piece of furniture would fit through a doorway, and you put your two arms up against the box like this and you have it open, and you keep that angle, and then you've got your two arms here. I'm assuming that your arms are not the same length. Maybe they are. Then you've got side, angle, side congruent to side, angle, side. And that's actually one method you could use to see if a box or a piece of furniture would go through a doorway. I know I used to use this a lot when I would rearrange furniture or switch rooms with my sister when I was younger. A nice application of side, angle, side. Let's look at this. What other information do you need to prove triangle DEF congruent to FGD? By side, angle, side. So the given is already marked. You can see that we are given EF congruent to DG. One thing I do know is that DF is congruent to DF by reflexive property. So I'm going to mark that because that is true and I've got a reason for that. But I need something else for side, angle, side. If I'm looking at this top triangle, EDF, side, angle, side would have to be this angle right here because it's the angle between the two sides I'm given. that angle would have to be equal to this angle down here because it's between the two sides I'm given. So what I need is I need angle EFD congruent to angle GDF. Notice you can't call that angle F or angle D. You have to use this three-letter notation. So that's what I need in order to prove these two congruent by side angle side. What other information do you need to prove these two triangles congruent by side angle side? Well, I know that LB is congruent to LB, reflexive. But what I need, I've got side angle, but I need another side. I need this side to be congruent to this side in order to have the two triangles congruent by side angle side. So I need LE to be congruent to BN. That's what I need. Okay, let's go over here. Would you use side, 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 or side angle side to prove the triangle's congruent? If there's not enough information to prove congruent, write not enough information. So let's analyze. Let's look at the first set. A, do I have side angle side congruent to side angle side? I do. So this one's yes. The second one, I have side angle side, and then this one I have angle side side. So this one is not enough information. Ooh, that looks horrible. Not enough info. Let's go to the next page and analyze these two. On the top one, it looks like I've got side, side, side here, congruent to side, side, side here, and that is a shortcut. So that is what makes these two triangles congruent. Down here for D, I've got three sides of one congruent to three sides of the other. But I also know because vertical angles are congruent that that's true. So I could also use side angle side. That's convenient. We're going to do two of these three proofs. Pause the movie, try this on your own, press play when you're finished. Just as a little reminder, make sure to mark the given on the diagram. Okay, now that you have tried this guy on your own, let's go through it. Let's look at what you should get. We've got RS congruent to UT, so let's mark that on the diagram. RT congruent to SU, let's mark that on the diagram. That's given. So for number one, we have given. ST congruent to ST, that's reflexive. Anything is equal to itself. Then, looking at the shortcut, what proves these two triangles congruent is my shortcut of side, side, side. Three sides of one triangle congruent to three sides of another, then the two triangles congruent. We're going to also do this proof. This one's got a little bit more of a challenge to it. It uses things we've done a long time ago. So pause the movie, try this on your own, and then press play when you're finished. Okay, we're given B is the midpoint of AD and EC. Interesting. So number one is given. Now, midpoint, the definition means middle point. So it's cutting it in half. So what allows me to say that AB is congruent to DB and that EB is congruent to CB? Well, that is because of the definition of midpoint. So I'm using the definition of the term I had in the previous statement. By definition of midpoint. ABC, this angle, is congruent to DB, not DBC, that's silly. This should be an E, make sure you change that. DBE. Reasoning for that. That's because vertical angles are congruent. Make sure you change that to an E. Now, what allows you to say that the two triangles are congruent? Notice, if I did not mark my diagram as I went through this proof, I would not know what shortcut to use. But as it is, I've marked my diagram and I can see that I have side, angle, side congruent to side, angle, side. So my shortcut is side, angle, side. Now this next proof can be used for retake contract work, extra practice, whatever you'd like. I know it's hard to make up a proof, so that is going to be used for any kind of extra work you need.